podcasts you love.
From people you trust.
This is TWiT.
This is TWiT News Special number 368, recorded Monday, April 12th, 2021. NVIDIA's GTC21 Keynote. Hello, everybody. Leo Laporte here, getting up early on a Monday morning because NVIDIA is about to speak. Jensen Huang, the founder and CEO of NVIDIA, is going to talk about the areas NVIDIA is venturing into. I think we don't normally cover NVIDIA's GTC or these keynotes. It's the first time we've done it, but I think there's good reason to. I think it's become pretty clear that with NVIDIA's growth in not only gaming, but cryptocurrency mining, self-driving vehicles, machine learning, this is a company on the move. And of course, with the announcement that they're attempting to acquire ARM, regulatory approval pending, that could mean a juggernaut, something to really compete with Intel and AMD. I thought, though, for today's event, it'd be best to have some expertise in-house. Sam Abuelsamid joins us, principal researcher at Navigant Research. He's the podcaster at wheelbearings.media. And of course, Sam is my car guy on the Tech Guy Show. Good morning, Sam.
Good morning, Leo. And it's no longer Navigant, it's now Guidehouse Insights. We got rebranded last year.
Pardon me. You knew it as Navigant, formerly known as
Navigant. A lot of people still remember us as Navigant, but it's Guidehouse Insights now. But yeah, pleasure to be here with you today to talk about NVIDIA.
Yeah, I mean, your expertise is cars, but you actually have been covering NVIDIA longer than I have. I've been an NVIDIA fan. I have an NVIDIA Shield, owned the first one, bought the new one. I've had many NVIDIA GPUs over the years. I'm currently using a 3080. NVIDIA is well known, but what they've really become expert in apparently is planning for the future. They're big in self-driving vehicles and machine learning. These are growth areas. You're going to be talking to NVIDIA later in the day. I know you're going to go to a briefing. What would you like to hear from Jensen Huang today? What do you expect to hear?
I think we're definitely going to be hearing some stuff today about what their next generation of chips for automated vehicles. But the fascinating thing about NVIDIA is seeing how they have grown from just doing GPUs, video cards for gaming, and leveraged that technology into a vast array of other applications, taking the highly parallelized processing of their GPUs and being able to take advantage of that for all kinds of different artificial intelligence applications and everything from medical research to robotics and automated vehicles, as well as populating data centers with their GPUs. So we'll be fascinated to hear what they're doing next. What are some of the new applications that they're using this technology for?
The NVIDIA stock has been kind of going down over the last few weeks and months. I'm not sure if it's because of the attempted ARM acquisition. That's a big acquisition, or maybe the market knows something about NVIDIA. It'd be interesting to watch what happens as Jensen Huang lays out his plans for the future of NVIDIA. Let's go right now to Jensen's kitchen for his GTC keynote.
Oh, there we go.
There are powerful forces shaping the world's industries. Accelerated computing that we pioneered has supercharged scientific discovery while providing the computer industry a path forward. Artificial intelligence, particularly, has seen incredible advances. With NVIDIA GPUs, computers learn, and software writes software no human can. The AI software is delivered as a service from the cloud, performing automation at the speed of light. Software is now composed of microservices that scale across the entire data center, treating the data center as a single unit of computing. AI and 5G are the ingredients to kickstart the fourth industrial revolution, where automation and robotics can be deployed to far edges of the world.
A couple of years ago, NVIDIA
there
made
is one more miracle we need.
An acquisition of a company called Mellanox,
a virtual world
who's
that is a
specialized in doing these very high-speed interconnects for data centers and multi-processor high-performance computing rigs. And they're starting to leverage that technology now, the Mellanox technology, into what they're doing.
The flow also reflects the waves of AI and how we're expanding the reach of our platform to solve new problems and to enter new markets. First is Omniverse, built from the ground up on NVIDIA's body of work. It is a platform to create and simulate virtual worlds.
Omniverse is a very interesting thing that NVIDIA announced last year, based on using multiple ray tracing GPUs, connecting many of their RTX GPUs together to create much more photorealistic environments for, especially for simulation.
AI, drug discovery, and quantum computing. Here I'll also talk about ARM and new ARM partnerships. The third stack is one of our most important new platforms, NVIDIA EGX with Aerial 5G. Now enterprises and industries can do AI and deploy AI on 5G. We'll talk about NVIDIA AI and pre-trained models like Jarvis Conversational AI. And finally, our work with the auto industry to revolutionize the future of transportation, NVIDIA Drive. We'll talk about new chips, new platforms and software, and lots of new customers. Let's get started. Scientists, researchers, developers, and creators are using NVIDIA to do amazing things. Your work gets global reach with the install base of over 1 billion CUDA GPUs shipped and 250 exaflops of GPU computing power in the cloud.
That's a lot of computing power.
And 7,500
NVIDIA's chips, their GPU cores are showing up almost everywhere now in all kinds of applications.
And we'll continue to put our heart and soul into advancing it. Building tools for the Da Vincis of our time is our purpose. And in doing so, we also help create the future. Democratizing high-performance computers is one of NVIDIA's greatest contributions to science. With just the GeForce, every student can have a supercomputer. This is how Alex Krzyzewski, Ilya, and Hinton trained AlexNet that caught the world's attention on deep learning. And with GPUs in supercomputers, we gave scientists a time machine.
Yes, Atlan is a thing. We'll be hearing a lot more about that later in the show.
In his lifetime. I can't think of a greater purpose. Let me highlight a few achievements from last year. NVIDIA is continually optimizing the full stack. With the chips you have, your software runs faster every year, and even faster if you upgrade. On our golden suite of important science codes, we increased performance 13-fold in the last 5 years.
One of the things that is interesting about NVIDIA is they've focused a lot on making sure that the CUDA software that developers build can continue to run as they keep introducing these new generations of their GPU architectures, and they can easily migrate from one generation to the next.
To do the largest atomic simulation ever, 305 million atoms. This work was critical to a better understanding of the COVID-19 virus and accelerated the making of the vaccine. Dr. Amaro and her collaborators won the Gordon Bell Award for this important work. I'm very proud to welcome Dr. Amaro and more than 100,000 of you to this year's GTC, our largest ever by double. We have some of the greatest computer scientists and researchers of our time speaking here. 3 Turing Award winners, 12 Gordon Bell Award winners, 9 Kaggle Grand Masters, and even 10 Oscar.
Yeah, the entire GTC event, virtual event this year is free. So all you have to do is go to NVIDIA.com and register, and you can see all of these sessions. You'll be able to watch all of them over the next week or two.
Enterprise IT company. They're bringing you their latest work in COVID research, data science, cybersecurity, new approaches to computer graphics, and the most recent advances in AI and robotics. In total, 1,600 talks about the most important technologies of our time, from the leaders in the field that are shaping our world. Welcome to GTC. Let's start where NVIDIA started, computer graphics. Computer graphics is the driving force of our technology. Hundreds of millions of gamers and creators each year seek out the best NVIDIA has to offer. At its core, computer graphics is about simulations. using mathematics and computer science to simulate the interactions of light and material, the physics of objects, particles, and waves, and now simulating intelligence and animation. The science, engineering, and artistry that we dedicate in pursuit of achieving Mother Nature's physics has led to incredible advances and allowed our technology to contribute to advancing the basic sciences, the arts, and the industries. This last year, we introduced the second generation of RTX, a new rendering approach that fuses rasterization and programmable shading with hardware-accelerated ray tracing and artificial intelligence.
I was at the CES keynote a few years ago when Jensen Huang first announced their real-time ray tracing capabilities. The demos they showed were just phenomenal.
It's amazing,
Let me
isn't
show
it?
you some amazing footage from games in development.
And now they're starting to use it for all kinds of other applications, some of which we're going to hear about today. They incorporated it last year into their Omniverse platform.
Is this Unreal Engine 5? Probably is, huh?
I think so, yeah.
Planet of the Apes, it looks like.
Yeah, it does, doesn't it?
You did it! You damn dirty apes! Oh, wow. Serpents in the sky. It's really, the ray tracing is dramatic, although it's so challenging. You have to have not only do you have to have an RTX card, you probably have to have a pretty heavy-duty PC to do it.
Yeah, I certainly need a chunky power supply to pull this off. But
and liquid cooling and...
Yep. But, when you start looking at the applications beyond video games, there's actually
that's why we're doing this.
More.
I mean,
yeah.
Games are one thing, and certainly that's NVIDIA's bread and butter probably still, but there's really so many other things NVIDIA does. It's one of the reasons we wanted to have you on, Sam, because of the automotive technology that they did. But it's all the same processors.
It's using
right?
the same core technology.
Yeah. You may not need ray tracing in your car, but you need real-time processing of a broad number of inputs in 3D and all of that.
Yeah, well, and it's not, one of the key things to think about with their SoCs, their system on a chip designs, is that there's a lot more to them than just GPU cores.
Right.
They all have ARM cores in there. They have like the Orin chip that they announced a couple of years ago, and it's going to production vehicles in 2022. It's based on 12 ARM Cortex A78 cores, and then several hundred CUDA GPU cores, the latest generation, the Ampere GPU cores, as well as tensor processing units and more.
Early 1990s novel Snow Crash, where the metaverse would be collectives of shared 3D spaces and virtually enhanced physical spaces that are extensions of the internet.
Zoom in on
pieces of the early metaverse vision.
Oh, does he have a fireplace in his kitchen? What
massive online social games like Fortnite or user.
I don't think it's a fireplace. I think it's just a very fancy backsplash. Let me tell you about
Omniverse from the perspective of two applications: design collaboration and digital twins. There are several major parts of the platform. First, the Omniverse Nucleus, a database engine that connects users and enables the interchange of 3D assets and scene descriptions. Once connected, designers doing modeling, layout, shading, animation, lighting,
and
special
Omniverse is using the Pixar Universal Scene Descriptor language that Alex talks a lot about on MacBreak Weekly.
Universal Scene Description, a fabulous interchange framework invented by Pixar. Multiple users can connect to Nucleus, transmitting and receiving changes to their world as USD snippets. The second part of Omniverse is the composition, rendering, and animation engine, the simulation of the virtual world. Omniverse is a platform built from the ground up to be physically based. It is fully path traced. Physics is simulated with NVIDIA PhysX, materials are simulated with NVIDIA MDL, and Omniverse is fully integrated with NVIDIA AI. Omniverse is cloud native.
This is actually really important for simulation, because one of the keys to making good simulations is you have to have fidelity between the simulation and your real world. Because as you get more and more sophisticated simulations, if you lose fidelity in there, if there starts to become a mismatch, if you have digital artifacts in there that cause mismatches, then the simulations all of a sudden don't become they're no longer useful, especially when you're talking about AI and image recognition.
Right. These are all talking about looks like ray traced renders with things like Blender and
it's pretty phenomenal. But when you start getting into areas like automated vehicles or some of the medical simulations,
real time is very important.
Not just real time, but also that fidelity, having a perfect match,
not losing synchronization with reality.
To bring together internal and external tool pipelines from multiple studios. Omniverse lets them collaborate, render final shots.
It's interesting that Bentley and BMW are included in the studios.
Ericsson is using Omniverse to do real-time 5G wave propagation.
BMW is using it for factory simulations, for factory automation simulations. And I'm not sure what Bentley's doing, but there's a lot of fascinating applications.
And Activision is using Omniverse to organize their more than 100,000 3D assets into a shared and searchable world. Bentley is the world's leading infrastructure engineering software company. Everything that's constructed, roads and bridges, rail and transit systems,
apparently not.
Airports and seaports, about 3% of the world's GDP, or $3.5 trillion a year. Bentley software is used to design, model, and simulate the largest infrastructure projects in the world. 90% of the world's top 250 engineering firms use Bentley. They have a new platform called iTwin, an exciting strategy to use the 3D model after construction to monitor and optimize the performance throughout its life. We're super excited to partner with Bentley to create infrastructure digital twins in Omniverse. Bentley is the first third-party company to be developing a suite of applications on the Omniverse platform. This is just an awesome use of Omniverse, a great example of digital twins, and Bentley is the perfect partner. And here's Perry Nightingale from WPP, the largest ad agency in the world, to tell you what they're doing.
WPP is the largest marketing services organization on the planet, and because of that, we're also one of the largest production companies in the world. That is a major carbon hotspot for us. We've partnered with NVIDIA to capture locations virtually and bring them to life in studios with Omniverse.
No more
Over
location
10 billion
shots, just do everything on a green screen.
Turned into a giant mesh in Omniverse. For the first time, we can shoot locations virtually that are as real as the actual places themselves. Omniverse also changes the way we make work. A collaborative platform that means multiple artists at multiple points in the pipeline in multiple parts of the world can collaborate.
They're giving away
real-time CGI
RTX 3090s, which may be the only and maybe easiest way to get one.
Film at WPP.
There's messages hidden inside of NVIDIA.
One of the most important features of Omniverse is that it obeys the laws of
mantelpiece.
Omniverse can simulate particles, fluids, materials, springs, and cables. This is a fundamental capability for robotics. Once trained,
you're giving away 4
RTX software can be
3090s.
downloaded from Omniverse.
Look for clues in the stream.
In this video, you'll see Omniverse's physics simulation with rigid and soft bodies, fluids, and finite element modeling.
I'm looking at his background.
Enjoy.
So you warned me normally Jensen Huang is long-winded, and these can be very long, but this is pre-recorded, and so we know it's exactly 60 minutes long.
Yeah.
Wow.
Some of the ones I've been through to a couple of live ones that have run 2.5 hours, but this is only going to be 60 minutes.
These are, I presume, demonstrations of the physics simulating capabilities.
Yeah, I think so. Yeah. Yeah, they're NVIDIA GPUs and SoCs are used extensively in medical research. He mentioned, some of the work that was done on COVID last year.
Isn't that cool? I can see why they want to take a little victory lap for that. Of course, decoding the genome of the virus and then using that to create an mRNA vaccine is a really good use of machine learning and processing.
And also, actually being able to model the virus molecule, understanding exactly the physical characteristics of it.
People who run folding at home, I think, probably understand a little bit the difficulty of doing this.
Oh, yeah.
Every Pantone color in the universe all smushed into one.
Omniverse is a physically based virtual world where robots can learn to be robots. They'll come in all sizes and shapes. Box movers, pick-and-place arms, forklifts, cars.
Now, this is another application I didn't think about.
In the future,
robots.
A factory will be a robot.
Yeah.
Orchestrating many
not
robots
too different
inside,
from
building cars,
self-driving vehicles, right? It's a real-time universe.
There are similarities, especially when you start looking at the sensors. When you're trying to and build the perception system, where you're taking the signal from the sensor and trying to understand in software what that thing is. Trying to recognize, is that a pedestrian? Is that a car? Is that a dog?
Right.
And that's where having that visual fidelity to the real world, and we've talked about this before, where very subtle changes to an image can totally confuse an AI, a neural network that's designed to do image recognition, can totally throw it off. And so, if you have a simulation that has, artifacts and has diverges from what the sensor is actually seeing, it could totally mess up and mischaracterize what is around the vehicle. So that fidelity is critical to having successful simulation for robotics or autonomous vehicles or anything else.
Welcome to BMW Production, Jensen. I'm pleased to show you why BMW sets the standards for innovation and flexibility. Our collaboration with NVIDIA Omniverse and NVIDIA AI
TechSpot,
leads into a new
Jensen pulled an A100 out of his oven.
Yes, he did.
Fantastic to be with you, Milan.
You're going to want to watch closely. There's hidden Easter eggs in here. Things like perhaps blinking lights with more signaling Morse code. And if you can identify them in the timestamp where you found them, tweet them to NVIDIA GTC with hashtag GTC Treasure. You could win one of 4 RTX 3090s. And they're giving away 20 Shield TVs, which, by the way, I love those Shield TVs. Well done, NVIDIA. Those are a really good example of what Integra
revolutionizes
BMW's that's also a great example of a device that they've actually continued to support for so many years, where a lot of stuff, a lot of those types of devices get abandoned after 2 or 3 years.
Planning experts located in different parts of the world, testing a new
They're not using man-like robots like that, are they?
One of them, Wormholes,
no.
simulation
No.
with the
BMW is not building cars with robot guys.
Yeah, no, I think they're using that, just to take the place of that would be a human doing that work.
I see. They're designing a assembly line space.
And safety.
Yes.
Can you tell how far I've been down there? So we'll get you a taller.
So they're working on the ergonomics of the
little taller
area.
Yeah, a little taller stand.
Scale in simulation.
That's exactly why NVIDIA has Digital Human for simulation. Digital humans are trained with data from real associates. You could then use digital humans.
How long before the digital humans take over is the question.
Workflows for worker ergonomics and efficiency.
And I'm glad they're wearing masks.
Yeah, that's going to take a little while.
7,000 people that share workspace with many robots designed to make their jobs easier. Let's talk about them.
You're right, Jensen. Robots are crucial for a modern production system.
There's that orange arm.
With NVIDIA Isaac Robotics platform, BMW is
the problem with trying to put digital humans in there is they still need power supplies, and so they're not as mobile as organic humans.
Since we produce 2.5 million vehicles
not as adaptable.
Back to the charger.
99% of them are custom.
Synthetic data generation and domain randomization available in Isaac are key to bootstrapping machine learning. Isaac Sim generates millions of synthetic images and vary the environment to teach the robots. Domain randomization can generate an infinite permutation of photorealistic objects, textures, orientations, and lighting conditions. It is ideal for generating ground truth, whether for detection, segmentation, or depth perception. Let me show you an example of how we can combine it all to operate your factory. With NVIDIA's Fleet Command, your associates can securely orchestrate robots and other devices in the factory for mission control.
512 in our chat is saying he's hoping they'll pull a 3080 Ti out of the oven. For some reason, NVIDIA has been very slow to release the Ti, the titanium versions of
robot missions,
high-end
and
RTX cards.
When a robot needs a helping hand, an alert
I'm still running on a 1080 Ti in my machine here that I'm streaming from.
Yeah,
the robot.
I think that's what we put on our
We're in the
virtual reality ultimate gaming machine 4 years ago. It was a 970.
I have the Star Wars edition.
The scale of BMW production is impressive, Milan.
Nice.
Indeed, Jensen. The scale and complexity of our production network
There's the BMW
requires BMW
iX.
to constantly innovate.
That's their
new
I'm
really
happy
crossover
about the
coming
tight
later this year.
collaboration between our two companies.
Look at that.
NVIDIA
That is the worst
Omniverse
grill.
and NVIDIA AI
We were talking about
give
the
us
grill the other day.
chance to simulate all 31 factories in our production network. These new innovations will reduce the planning times, improve flexibility and precision, and at the end, produce
Allow our grills
30%
to be
more
bigger
efficient
and
planning
bigger.
processes.
Milan, I could not be more proud of the innovations that our collaboration is bringing to the factories of the future. I appreciate you hosting me for a virtual visit of the digital twin of your BMW production.
That might be a code.
It is a work of art.
No need for a license plate in the factory.
The ecosystem is really excited about Omniverse. This open platform with USD Universal 3D Interchange connects them into a large network of users. We have 12 connectors to major design tools already, with another 40 in flight. Omniverse connector SDK is available for download now. You can see that the most important design tools are already signed up. Our Lighthouse partners are from some of the world's largest industries: media and entertainment,
all in
gaming,
alphabetical order.
architecture, engineering, construction, manufacturing,
no
telecommunications, infrastructure, and automotive. Computer makers worldwide are building NVIDIA-certified workstations, notebooks, and servers optimized for Omniverse. And starting this summer, Omniverse will be available for enterprise license. Omniverse, NVIDIA's platform for creating and simulating shared virtual worlds. Data center is the new unit of computing. Cloud computing and AI are driving fundamental changes in the architecture of data centers. Traditionally, enterprise data centers ran monolithic software packages. Virtualization started the trend towards software-defined data centers, allowing applications to move about and letting IT manage from a single pane of glass. With virtualization, the compute, networking, storage, and security functions are emulated in software running on the CPU. Though easier to manage, the added CPU load reduced the data center's capacity to run applications, which is its primary purpose. This illustration shows the added CPU load in the gold-colored part of the stack.
Before the event started, I was talking, I think you were still trying to get connected, about Mellanox, which is a company that NVIDIA acquired a couple of years ago. And their big thing was they created very high-performance interconnect systems for data centers and for supercomputers. So when you've got racks of dozens or hundreds or thousands of these cards running this stuff, being able to transfer the data back and forth in there is really crucial. And last year at GTC, Jensen announced a new type of processor they call the DPU, the Data Processing Unit. It's based on Mellanox's technology. They call it Bluefield. And I think we'll be hearing more about Bluefield today.
Overnight, consumer AI services became the biggest users of GPU supercomputing technologies. Now, adding zero-trust security initiatives makes infrastructure software processing one of the largest workloads in the data center. The answer is a new type of chip for data center infrastructure processing.
There we go.
Like NVIDIA's Bluefield DPU. Let me illustrate this with our own cloud gaming service, GeForce Now, as an example. GeForce Now is NVIDIA's GeForce in the Cloud service. GeForce Now serves 10 million members in 70 countries.
It's amazing.
Incredible.
It works really well.
GeForce Now is a seriously hard consumer service to deliver. Everything matters. Speed of light, visual quality, frame rate, response, smoothness, startup time, server cost, and most important of all, security. We're transitioning GeForce Now to Bluefield. With Bluefield, we can isolate the infrastructure from the game instances and offload and accelerate the networking, storage, and security. The GeForce Now infrastructure is costly. With Bluefield, we will improve our quality of service and concurrent users at the same time. The ROI
That's the
Bluefield
biggest
is
problem
excellent.
in these
I'm thrilled to announce our
server
first data center
gaming
infrastructure SDK.
field is
Doka
you have
1.0 is available
30 million
today.
customers, but
Doka is our SDK
you
to
get
program
spikes in
There's all kinds of great technology.
users.
Yeah, it's not.
And it's very hard to build the
utilization.
infrastructure
Secure boot,
economically because you have to plan for the
regular
biggest
expression
spike.
acceleration,
This
and a
solves
very
that problem,
exciting
I
capability.
think.
A hardware-based,
It certainly contributes
real-time
to
clock
solving it, yeah.
that can be used for synchronous
What was
data
that
centers,
original
5G,
game streaming
and video
service?
broadcast.
Yeah, they went out of
Great
business
partners
because they
working with
couldn't
us
do
to
it.
optimize leading platforms
Yeah,
on
they had to
Infrastructure
They couldn't
software
scale.
build out,
Edge
you know,
and
for
CPU
their peaks, which only accounted for a small percentage of their total
and
usage
storage
time.
providers.
Right.
Basically, the world's leading companies in data center infrastructure. Though we're just getting started with Bluefield 2, today we're announcing
So this is an
Bluefield 3,
interconnect, basically.
22 billion
Yeah,
transistors.
and it accelerates the
400 gigabit
data
per second
transfer
networking.
between devices.
16 ARM CPUs to run the entire virtualization software stack. For instance, running VMware ESX.
That really
Bluefield 3
solves some
takes
problems. If
security
you don't
to a
have a
whole
user
new
tied
level.
to a particular
Fully offloading,
processor,
accelerating IPsec and TLS
you can
cryptography.
makes it much easier to
secret key
scale, I
management,
think.
And regular
On
expression
live.
processing.
That's right. Thank you, Keith.
We're on
live,
pace to
yep,
introduce
that's
a
on
new
live.
Bluefield generation every 18
And of course,
months.
they failed because of it.
Bluefield 3
And
will do
Sony
400
ended up
gigabits per
buying their
second
assets, I
and
think,
be
right?
10x
Sony bought
across the
Gaikai. I
capability
can't remember if they bought on. Somebody bought on live. Yeah.
Bluefield 4.
But it was IP
will do
probably more
800
than
gigabits per
anything
second
else.
Yeah.
And add NVIDIA's AI computing technologies to get another 10x boost. 100x in 3 years.
Key 512.
And
Expect
all
an
of it
SoC
will
with
be needed.
GPU, CPU, and
A simple way to think
DPU,
about
or the
this
Raspberry Pi
is that
5.
A third of the roughly 30 million data center
Of
servers
course,
shipped each
NVIDIA
year
is in the process of
are
buying ARM.
consumed running the software-defined data
That's
center
going to be
stack.
it's one of the things that makes
This
NVIDIA
workload
probably
is
one of the most
increasing much
interesting
faster
companies
than
in the
Moore's
space.
law. So unless we
As
offload and
Intel
accelerate this
fades,
workload,
NVIDIA is
data
coming on
centers will have
strong.
fewer
And with
fewer
ARM,
And this is
to run
one thing that I've
applications.
actually found kind of
The time for
surprising
Bluefield
is that, with
At
all
the
the talk
beginning,
since
at the
the
Big
Apple
Bang of
M1 was
modern
announced,
AI, we
why
recognized the need to
I'm
create a
surprised
new
that
kind of
nobody has
computer
talked about
for a new way of
instead of
developing
Qualcomm using
software
NVIDIA
will be written by software
to
run
produce
by AI
a
computers.
new generation of
This new type
chips
of computer will
for
need new chips,
for
new
Windows-based
system
machines.
architecture,
Because
new ways to network,
for years they've
new
been producing
software,
ARM-based
and new
SoCs.
methodologies and tools.
Right.
And combining that with
We've
their
invested
GPU technology, I
billions
mean,
into
can you
this
imagine a
integration, and that's
Windows,
proven helpful to the
a fanless Windows
together
laptop
as DGX,
with an NVIDIA
computer for
SoC in there
We offer
with
DGX
ARM
software
cores
integrated
and
system,
their
as well
GPUs?
as offer the components to the industry to create differentiated options. I'm
Yeah, the
pleased to see so
integration,
much
the
AI
vertical
research
integration
advancing
is-
because of DGX.
Yeah.
Top universities,
Horizontal integration
research
is
hospitals,
very interesting.
telcos, banks, consumer products companies.
I think they're building a
car
juggernaut,
makers,
frankly.
and aerospace companies.
Oh, yeah.
DGX helped their AI researchers whose expertise is rare, scarce, and their work strategic. It is imperative to make sure they have the right
There's
instrument.
Microsoft, Google,
Simply, if software
Amazon
is to be
all
written by
have some
computers,
form of
then companies with the best
GPU in the
software
cloud
engineers
for
will
machine
also
learning
need the
and
best computers.
AI researchers.
We offer several configurations, all software compatible. The DGX A100 is a building block that contains 5 petaflops of computing and super fast storage and networking to feed it. DGX Station is an AI data center in a box, designed for work groups, plugs into a normal outlet. And DGX SuperPod is a fully integrated, fully network optimized AI data center as a product. SuperPod is for intensive AI research and development. NVIDIA's own new supercomputer called Selene is 4 SuperPods. It is the 5th fastest supercomputer and the fastest industrial supercomputer in the world's top 500.
See,
We have a new
and I bought an
DGX
Alienware.
Station 320G.
I got a super pod.
DGX Station
You
can
could have just
train
bought a
large
DGX
models.
A100.
320 gigabytes of super fast HBM2E connected to 4 A100 GPUs. Over 8 terabytes per second of memory bandwidth. 8 terabytes
just plug it into the
transferred in
wall.
1 second.
Yeah.
It would take 40 CPU
better have a
servers
240
to
amper.
achieve
I think
this
your solar panels could almost power one
DGX
of these.
Station plugs into a normal wall outlet, like a big gaming rig. Consumes just 15
That's only 1.5
watts,
kilowatts. That's
and
not
it's
big.
liquid
Look how quiet it
silent
is.
37
My
dB.
Alienware is louder than that.
Take a look at the cinematic that our
37
engineers and
dB.
production team did.
Yeah, I think people underestimate what an NVIDIA ARM combination could mean. Oh man, look at that.
Absolutely.
They don't build PCs, but that's pretty. Wow. I want one. 64 core PCI 4th gen, 4 gigabyte GDDR6 GPU memory. That's just the card. Look how many video cards they have in there. I love that 7.6 terabyte NVMe SSD. Standard plug. Uses just plug it into the wall. Refrigerant coolant. That is nice. When can I get that?
A CPU cluster of this performance would cost
I think you can get them now.
Today. DGX Station is $149,000. The ideal AI programming companion for every AI researcher. Today, we're also announcing a new DGX.
And I bet it doesn't run Windows.
3 major upgrades. The new 80 gig A100, which brings the SuperPod to 90 terabytes.
Really
I think it's got more than enough power to run Windows in a virtual machine.
In virtualization, exactly.
Exabytes per second.
Run a couple of hundred instances of Windows Virtual.
This bandwidth.
But it still can't run Cyberpunk 2077.
Yeah.
15 times bigger than the SuperPod. Second, SuperPod has been upgraded with NVIDIA Bluefield 2. SuperPod is now the world's first cloud-native supercomputer, multi-tenant shareable, with full isolation and bare metal performance. And
see, of course, what you're going to do is you're going to rent this in the cloud. You're going to get it from DigitalOcean,
the DGX management and orchestration
or somebody like that.
We use Base Command to support thousands of engineers, over 200 teams, consuming 1 million plus
and I imagine
hours
Pixar
a week.
Buy 3 or 4.
DGX SuperPod starts at $7 million and scales to $60 million for a full system. Let me highlight 3 great uses of DGX. Transformers have led to dramatic breakthroughs in natural language processing. Like RNN and LSTM, transformers are designed to inference on sequential data. However, transformers, more than meets the eyes, are not trained sequentially, but use a mechanism called attention, such that transformers can be trained in parallel. This breakthrough reduced training time.
That explains Optimus Prime.
More importantly, enabled the training of huge models with a correspondingly enormous amount of data. Unsupervised learning can now achieve excellent results, but the models are huge. Google's Transformer was 65 million parameters. OpenAI's GPT-3 is 175 billion parameters.
Yeah, that's amazing.
That's 3,000 times larger in just 3 years. The applications for GPT-3 are really incredible. Generate document summaries, email phrase completion.
That same kind of growth is what's happening. Has been happening in the autonomous vehicle space as well, which is why, if you go back to like 2014, 2015, when NVIDIA was first getting into that space, the processors that they were pitching for autonomous vehicle development were, like some of the Maxwell era, and Parker era SoCs, which were basically the high-end Tegras, and now they're up to Orin, which they introduced last year, which is a 254 teraops SoC. And later we'll be hearing about what's next after that.
Megatron trains giant transformer models. It partitions and distributes the model for optimal
so they're acknowledging that transformer name leads to some
Megatron does fast data loading, micro-batching, scheduling and syncing, kernel fusing, and pushes the limits of every NVIDIA invention. Nickel, NVLink, InfiniBand.
It's really impressive what they're doing.
Even with Megatron, a trillion parameter model will take 3 to 4 months to train on Selene. So lots of DGX SuperPods will be needed around the world. Inferencing giant transformer models is also a great computer science challenge. GPT-3 is so big, with so many floating point operations, that it would take a dual CPU server over a minute.
I think this focus on all these other areas, these other applications of their technology is also one of the potential advantages that they have over AMD. It's helped them to advance at an even faster pace than what AMD's managed on the graphics side.
Today,
people forget AMD is not a big company with not far from infinite resources. AMD isn't in a position to buy NVIDIA. To buy ARM. But NVIDIA is. I mean, that's very telling. And for a premium, I think 22 billion they offered, 20 billion.
No, I think it was 40 billion.
40? Wow.
Yeah.
Where a 1 minute response is
That's right. Yeah, because it was valued at 32. So
Naver is Korea's #1 search engine. They installed the DGX SuperPod and are running their AI platform Clova to train language models for Korean. I expect many leading service providers around the world to do the same. Use DGX to develop and operate region-specific, industry-specific language services. NVIDIA Clara Discovery is our suite of acceleration libraries created for computational drug discovery. From imaging, to quantum chemistry, to gene variant calling, to using NLP to understand genetics, and using AI to generate new drug compounds. Today, we're announcing 4 new models available in Clara Discovery. Mega Malbart is a model for generating biomolecular compounds. This method has seen recent success within cellular medicine, using AI to find a new drug.
I have no idea.
2 years.
Yeah.
NVIDIA ATAC-seq.
It's probably not a lot of customers, but I think that they sell a lot of units to those customers. Amazon, Google, and so on. They're probably running tens of thousands of these devices.
Gatortron is the world's largest
clinical language. This is another interesting thing that I think people don't think about it enough around NVIDIA is not just the hardware, but also the software that they do. A lot of the stuff that's running on these NVIDIA servers, these data centers, is based on software that they've developed in-house, and they provide it, as part of the package. When you buy, DGX, in many cases you'll get access to these software models, and they do the same thing in the vehicle space as well. So they have a full NVIDIA Drive AV software stack, and also what they call their IX software stack, their intelligent cockpit software stack, that you can it's evolved to the point where you can basically take that almost off the shelf and plug it into your vehicle and have a nearly production ready system.
Another model called Medica.
How much credit goes to Jensen Huang for this? Did he build this business? I mean,
he has certainly led the company. He's been the CEO since it was founded 28 years ago.
This is a gold standard.
He's been there from day one.
Pharma is a
I think
$1.3 trillion.
I think he certainly deserves credit, for setting the vision for the company. Much like Steve Jobs. Jobs didn't personally develop all this stuff.
I'm not saying that, but here you're taking a company that basically was making cards for video games, and you've found ways to take this technology and expand it into so many different markets. That's some vision. That's some leadership. I think from all that I've heard from talking to people at NVIDIA, Jensen really understands this stuff. Even though he's not the one necessarily developing it, he has that vision, and when people come into him with ideas, he understands what they're talking about. He's a technical guy. Yeah, it's clear just listening to him talk. He has an enthusiasm and an understanding for this. It's not, he's not reading it off a prompter. Well, he is, but
actually, he probably isn't.
Really?
I know when they did the live keynotes, he does not work from a prompter.
It is the most powerful.
That's impressive.
They'll have, they'll throw the slides up there with, whatever bullets are on there. That's all he's got to work with. Everything else, he's doing it off the cuff.
Quantum computing is a field of physics that studies the use of natural quantum behavior, superposition, entanglement, and interference to build a computer. The computation is performed using quantum circuits that operate on quantum bits called qubits. Qubits can be 0 or 1, like a classical computing bit, but also in superposition, meaning they exist simultaneously in both states.
Or 2.
The qubits can be entangled,
or anywhere in between,
where the behavior of one can affect or control the behavior of others. Adding and entangling more qubits let quantum computers calculate exponentially more information. There's a large community around the world doing research in quantum computers and algorithms. Well over 50 teams in industry, academia, and national labs are researching the field. We're working with many of them. Quantum computing can solve exponential order complexity problems, like factoring large numbers for cryptography, simulating atoms and molecules for drug discovery, finding shortest path optimizations, like the traveling salesman problem.
I think at this point, quantum computing is the shortest past the government funding.
Quantum states.
Yes.
Still a somewhat unproven technology. But.
So error correction is essential. It is estimated that,
but for a company like NVIDIA, it's also something you really can't afford to ignore.
Absolutely, yeah.
The research community is making fast progress, doubling physical qubits each year. So likely achieving the milestone by 2035 to 2040, well within my career horizon. In the meantime, our mission is to help the community research the computer of tomorrow with the fastest computer of today. Today, we're announcing.
So clearly, he's planning to stick around longer than Tim Cook.
An acceleration library designed for simulating quantum circuits.
So this is an example of software designed for quantum computers.
And state vector solvers. It is optimized to scale to large GPU memories, multiple GPUs, and multiple DGX nodes.
Oh, it's a simulator.
The speed up of cuQuantum on DGX is excellent. Running the cuQuantum benchmark, state vector simulation takes 10 days on a dual CPU server, but only 2 hours on a DGX A100. cuQuantum on DGX can productively simulate tens of qubits. And Caltech, using Contengra QMB, simulated a Sycamore quantum circuit.
On a Celeron, it's even slower.
In record time. Using cuQuantum on NVIDIA's Selene supercomputer. What would have taken years on CPUs can now run in a few days on cuQuantum and DGX. cuQuantum will accelerate quantum circuit simulators.
So is that a slide
researchers can design better quantum computers and verify the results.
What's that?
So he's triggering the slides on this?
Classical systems.
Yeah.
And discover more quantum optimal algorithms.
And like I said, I think, more than likely this is, he's not reading a script off a prompter. This is the same way he does the live keynotes. He's got the slides just as a prompt.
As close to live as possible. It's not heavily edited. There's not a lot of rolled in video. It feels like he just did this in maybe not in one take, but just kind of did it in real time. That's why I'm curious about the clicker, because, if you're doing it in post, you don't need a clicker.
Designed for a high number of cores, low cost, and great energy efficiency. Storage servers are optimized for a large number of cores and high I/O throughput. Deep learning training servers are built like supercomputers, with the largest number of fast CPU cores, the fastest memory, the fastest I/O, and high-speed links to connect to GPUs. Deep learning inference servers are optimized for energy efficiency. And best
very interesting in light of the ARM acquisition, because one of the things that ARM has some real potential for is in the data center.
Good job using configurations of CPU.
And
that's
I
one
think
area
we'll
where Intel
more
still dominates, but I don't think for much longer.
Yeah, I think we'll see more of the combined chips that they do. ARM CPUs, GPUs, DPUs. On single pieces of silicon.
Here's an example. You see an x86 gating the throughput from the GPU to the RAM.
Of super fast memory, running at 2 terabytes per second. Together, the 4 amperes process 320 gigabytes at 8 terabytes per second. Contrast that with CPU memory, which is 1 terabyte large, but only 0.2 terabytes per second. The CPU memory is 3 times larger, but 40 times slower than the GPU. We would love to utilize the full 1,320 gigabytes of memory in this node to train AI models. So why not something like this? Make faster CPU memories, connect 4 channels to the CPU, a dedicated channel to feed each GPU. Even if a package can be made, PCI Express is now the bottleneck. We can surely use NVLink. NVLink is fast enough, but no x86 CPU has NVLink, not to mention 4 NVLinks. Today, we're announcing our first data center CPU, Project Grace. Named after Grace Hopper, a computer scientist and U.S. Navy Rear Admiral, who in the 50s pioneered computer programming.
Happy about this.
Grace is ARM-based and purpose-built for accelerated
Grace is ARM-based.
Of large amounts of data such as AI. Grace highlights the beauty of ARM. Their IP model allowed us to create the optimal CPU for this application, which achieves X-factor speedup. The ARM core in Grace is a next-generation off-the-shelf IP for servers. Each CPU will deliver 300 spec int, with a total of over 2,400 spec int rate CPU performance for an 8 GPU DGX. For
this is parallelism. This kind of massive parallelism is really
the highest performance computer
right in their
the
wheelhouse. This is what they do.
450.
And it makes perfect sense. Why have a bottleneck with an x86 processor when you can just massively parallel 4 ARM processors?
Today. So look at this again. Before, after.
Mm-hmm.
Before, after.
Are you getting the picture?
Amazing increase in system and memory bandwidth. Today, we're introducing a new kind of computer, the basic building block of the modern data center. Here it is.
He is virtual. I knew it. Oh, look at that. Oh, that is cool. There goes the TI. It was in the oven, but it's gone
What I'm
now.
about to show you brings together the latest GPU-accelerated computing, Mellanox high-performance networking,
virtual Jensen,
and something brand new. The final piece of the puzzle.
A little uncanny valley. Man, I bet that thing could crack my Bitcoin
first
password.
CPU designed for terabyte scale accelerated computing.
That's how I could pay for it.
Grace. This powerful ARM-based CPU gives us the third foundational technology for computing and the ability to re-architect every aspect of the data center for AI. We're thrilled to announce the Swiss National Supercomputing Center will build a supercomputer powered by Grace and our next generation GPU. The new supercomputer,
the latest
called
supercomputers
ELPS,
have been ARM
will be
processors.
20
They have been ARM
exabytes
powered.
for AI. 10 times faster than the world's fastest supercomputer today. ELPS will be used to do whole Earth scale weather and climate simulation, quantum chemistry, and quantum physics for the Large Hadron Collider. ELPS will be built by HP Enterprise and come online in 2023. We're thrilled by the enthusiasm of the supercomputing community, welcoming us to make ARM a top-notch
Folks, I really believe that you're
platform.
seeing the future of computing.
Our data center roadmap is now a rhythm consisting of 3 chips: CPU, GPU, and DPU. Each chip architecture has a 2-year rhythm with likely a kicker in between. 1 year will focus on x86 platforms. 1 year will focus on ARM platforms. Every year, we'll see new exciting products from us. The NVIDIA architecture and platforms will support x86 and ARM, whatever customers and markets prefer.
Until we complete the acquisition of ARM.
Yearly leaps, one architecture. ARM is the most popular CPU in the world.
And then the automotive chips combine all of those onto a single piece of silicon.
It's super energy efficient.
You have to think at this point, x86 is completely legacy. They're going to support it for legacy reasons, but it's not the
ARM is used
future.
broadly in mobile and embedded today. For other markets like the cloud, enterprise, and edge data centers, supercomputing, and PCs, ARM is just starting and has great growth opportunities. Each market has different applications and has unique systems, software, peripherals, and ecosystems. For the markets we serve, we can accelerate ARM's adoption. Let's start with the big one, cloud. One of the earliest designers of ARM CPUs for data center is AWS. Its Graviton CPUs are extremely impressive. Today, we're announcing NVIDIA and AWS are partnering to bring Graviton 2 and NVIDIA GPUs together. This partnership brings ARM into the most demanding cloud workloads, AI and cloud gaming. Mobile gaming is growing fast and is the primary form of gaming in some markets. With AWS-designed Graviton 2, users can stream ARM-based applications and Android games.
Apple parallelized the M1 in this off-the-shelf ARM GPU architecture, and Apple has a serious Pro machine. Yeah, except I don't think we'll see Apple teaming up with NVIDIA again anytime in the foreseeable future.
Computing's Ultra CPU is excellent.
It's too bad because there is this animosity between the two of them, and it's unfortunate because
with the highest performance
I really think NVIDIA is the future.
But therein lies an incredible opportunity for Microsoft. You know, if they really want to make Windows on ARM a thing, you know, this is the company they should be partnering with.
Very smart to partner with NVIDIA at this point.
And reference system.
Because Qualcomm
Marvell Opteon
clearly is
excels
not
at
up to the
I/O,
task,
storage, and
or
5G
just doesn't seem interested.
This system is ideal for hypercomputing.
They're really become a patent licensing company. They're not innovating at this point. They're rent.
Oh, there you go. There's the PC reference.
PCs.
Yeah.
MediaTek is the world's largest SoC maker. Combining NVIDIA GPUs and MediaTek SoCs will make excellent PCs and notebooks. AI,
yeah, I think Microsoft is the big winner here.
computers
Exactly
automating
right.
intelligence, is the most powerful technology force of our time. We see AI in 4 waves. The first wave was to reinvent computing for this new way of doing software. We're all in and have been driving this for nearly 10 years. The first adopters of AI were the internet companies. They have excellent computer scientists, large computing infrastructure,
And if you're Apple and you're going to build an augmented reality or mixed reality headset, you're not putting an x86 chip in it.
No, definitely not.
Where AI can revolutionize the world's largest industries, from manufacturing, logistics, agriculture, healthcare, financial services, and transportation. There are many challenges to overcome, one of which is connectivity, which 5G will solve. And then autonomous systems. Self-driving cars are an excellent example, but everything that moves will eventually be autonomous. The industrial edge in autonomous
that's a
systems
big statement.
are the most
Everything that
challenging,
moves
but also the largest
eventually be
opportunities for AI
autonomous.
to make an impact. $1 trillion industries.
I mean,
can
on
soon
an
apply
infinite
AI to
timeline, as John
Yeah,
Syracuse would
eventually
say.
it could be.
new products, services, and business models.
In the year
We have
25,
to make AI
Eventually is a long
Turn AI
time.
from computer
if
science
man is still
to
alive.
computer products. We're building the new computing platform for this fundamentally new software approach, the computer for the age of AI. AI is not just about an algorithm. Building and operating AI is a fundamental change in every aspect of software. Andrej Karpathy rightly called it Software 2.0. Machine learning at the
Andrej
highest
Karpathy
level
is
is a
the current head of
continuous learning
autopilot
system
at Tesla.
that starts with data scientists developing data strategies and engineering predictive features.
And Tesla,
This data
of course,
is the
has
digital life
since
experience of a company.
ended the
Training
use
involves
of NVIDIA
inventing
chips
or
in their
adapting an AI model
self-driving
that learns to make
autopilots.
design
Interesting.
They
predictions.
switched to their own in-house design.
do their
Simulation
own.
and validation.
Yeah, I think a
Test
mistake.
the AI application for accuracy, generalization, and potential bias.
But very Elon.
And finally, orchestrating a fleet of computers.
I think this is
Elon
going to be
Musk
Apple's
will
fault.
data center
It's
at
a
the
certain
edge
kind
of
of
the
hubris
warehouse,
where,
farms,
if
or
we don't
wireless
make it,
base stations.
we don't want to
NVIDIA
use
created
it.
Chips, systems, and libraries needed for end-to-end machine learning. For example, technologies like
Samsung
Tensor Core
actually
GPUs,
fabricates those chips
NVLink,
for
DGX,
Tesla at
cuDNN,
their
Rapid,
Austin
Netcode,
foundry.
GPU Direct, Doken,
NVIDIA is
and so
fabless, though,
much
right? They
more.
don't make anything.
We call
Yeah,
the
right.
platform
Most of the
AI.
NVIDIA stuff is produced by TSMC.
NVIDIA AI libraries
Right.
accelerate every step.
By the way, that
From
might
data
be
processing
the
to
source of the
pre-orchestration.
animosity because, of course,
NVIDIA
Apple
AI is
tries to buy up all of
integrated into all
TSMC's
of the
production.
industry's popular tools and
Yeah.
workflows.
No, well,
AI
I
is
think
in every cloud.
the
Used by the world's
tensions
largest
between
companies
Apple
and by
and
over
NVIDIA go back
7,500
to,
AI startups
if
around
you
the
remember,
world. And NVIDIA
about
AI
10 or
runs
11
on
years
any
ago,
system that includes NVIDIA
in the
GPUs.
MacBook Pros,
From PCs
they
and
offered
laptops
a discrete
to
NVIDIA
workstations
GPU in
to
there.
supercomputers.
And there was one
any
series of
cloud
those that had
to a
problems with the
$99
GPU.
Jetson robot
And I
computer.
think there were some
segment
issues
of
about
computing
who would
is now
pay for
served
those warranty repairs.
Enterprise
Right.
computing. 70% of the world's enterprise run VMware, as we do at NVIDIA. VMware was created to run many applications on one virtualized machine. AI, on the other hand, runs a single job, bare metal, on multiple GPUs and often multiple nodes. All of the NVIDIA optimizations for compute and data transfer are now plumbed through the VMware stack, so AI workloads can be distributed to multiple systems and achieve bare
Interesting.
metal performance. The VMware stack is also offloaded and accelerated on NVIDIA Bluefield. NVIDIA AI now runs in its full glory on VMware, which means everything that has been accelerated by NVIDIA AI now runs great on VMware. AI applications can be deployed and orchestrated with Kubernetes running on VMware Tanzu. We call this platform NVIDIA EGX for Enterprise. The enterprise IT ecosystem is thrilled. Finally, the 300,000 VMware enterprise customers can easily build an AI computing infrastructure that seamlessly integrates into their existing environment. In total, over 50 servers from the world's top server makers will be certified for NVIDIA EGX Enterprise.
We're saying goodbye to Sam now because he's got to go to a press briefing from NVIDIA, which starts in about 15 minutes. Jensen Huang's been talking for almost an hour now. I suspect he's about to wrap up.
Workloads like Omniverse or Mix and Match all run NVIDIA AI. Enterprise companies make up the world's largest industries, and they operate at the edge. In hospitals, factories, plants, warehouses, stores, farms, city and roads, far from data centers. The missing link is 5G. Consumer 5G is great, but private 5G is revolutionary. Today, we're announcing the Aerial A100, bringing together 5G and AI into a new type of computing platform designed for the edge. Aerial A100 integrates the Ampere GPU and the Bluefield DPU into one card. This is the most advanced PCI Express card ever created. So it's not a surprise that Aerial A100 in an EGX system will be a complete 5G base station. Aerial A100 delivers up to full 20 gigabits per second and can process up to 9 100 megahertz massive MIMO for 64T, 64R, or 64 transmit and 64 receive antenna arrays. State-of-the-art capabilities. Aerial A100 is software-defined with accelerated features like PHY, virtual network functions, network acceleration, packet pacing, and line rate cryptography. Our partners, Ericsson, Fujitsu, Mavenir, Altran, and Redsys, will build their total 5G solutions on top of the Aerial library. NVIDIA EGX server with Aerial A100 is the first 5G base station that is also a cloud-native, secure AI edge data center. We have brought the power of the cloud to the 5G edge. Aerial also extends the power of 5G into the cloud. Today, we're excited to announce that Google will support NVIDIA Aerial in the GCP cloud. I have an important new platform to tell you about. The rise of microservice-based applications and hybrid cloud has exposed billions of connections in a data center to potential attack. Modern zero-trust security models assume the intruder is already inside, and all container-to-container communications should be inspected, even within a node. This is not possible today. The CPU load of monitoring every piece of traffic is simply too great. Today, we're announcing NVIDIA Morpheus, a data center security platform
Matrix
for real-time all-packet inspection. Morpheus is built on NVIDIA AI, NVIDIA Bluefield, NetQ network telemetry software, and EGX. We're working to create solutions with industry leaders in data center security: Fortinet, Red Hat, Cloudflare, Splunk, F5, and Area Cybersecurity. And early customers Booz Allen Hamilton, Best Buy, and of course, our own team at NVIDIA. Let me show you how we're using Morpheus at NVIDIA.
Did he say Best Buy?
It starts with a network. Here we see a representation
of these things is not like the
dots
other.
are servers, and lines, the edges, are packets flowing between those servers. Except in this network, Morpheus is deployed. This enables AI inferencing across your entire network, including east-west traffic. The particular model being used here has been trained to identify sensitive information, AWS credentials,
We're watching
the
semi-live keynote from NVIDIA's GTC conference. This is kicking off. Jensen Huang, CEO of NVIDIA, speaking from his kitchen, as he does every year, I guess, or at least he's done in the last 2 years.
This update accidentally removed encryption. And now everything that communicates with that app...
It's really become clear that NVIDIA has its fingers in a whole lot of computing pies, and especially in the future of computing.
This translates to continuing...
I think that's one of the reasons that our coverage of NVIDIA is going to increase over the next few years.
Any of these credentials, continually flagging when it encounters such data. And rather than using pattern matching, this is done with a deep neural network, trained to generalize and identify patterns beyond static rule sets. Notice all of the individual lines. It's easy to see how quickly a human could be overwhelmed by the vast amount of data coming in. Scrolling through the raw data gives a sense of the massive scale and complexity that is involved. With Morpheus,
things the human brain is really good at. It's very slow compared to a microprocessor, but it's massively parallel.
we show
And what I think you're seeing here is parallelism in silicon as an attempt to get closer to the human brain. This is something Jeff Hawkins has been working on for a long time, formerly of Palm, a neuroscientist himself. He's very aware of the high parallelism of the human brain. His book on intelligence talks about this. And it's something that has always been a challenge for traditional Turing machines. They're very linear.
With Morpheus, the chaos becomes manageable.
The IT ecosystem has been hungry for an AI computing platform that's enterprise and edge ready. NVIDIA AI on EGX with Aerial 5G is the foundation of what the IT ecosystem has been waiting for. We are supported by leaders from all across the IT industry, from systems, infrastructure,
I think the big risk for NVIDIA, though,
storage and security, data analytics,
having so many irons and so many fires could dilute their attention and dilute their capabilities. I think it's a little risky.
To complete our enterprise offering, we now have NVIDIA AI Enterprise software, so businesses can get direct line support from NVIDIA. NVIDIA AI Enterprise is optimized and certified for VMware and offers services and support needed by mission-critical enterprises. Deep learning has unquestionably revolutionized computing. Researchers continue to innovate at light speed with new models and new variants. We're creating new systems to expand AI into new segments like ARM, Enterprise, or 5G Edge. We're also using the systems to do basic research in AI and building new AI products and services. Let me show you some of our work in AI, basic, and applied research. DLSS, Deep Learning Super Sampling. StyleGAN, AI High-Resolution Image Generator. GANcraft, a neural rendering engine turning
stock
Minecraft
market's taking
into
notice of
realistic
this.
3D.
The NVIDIA stock is up
3D turns photographs
2%, almost 3%
models.
Today.
Face Vid to Vid, a talking head rendering engine that can reduce streaming bandwidth by 10x while reposing the head and eyes. Sim to Real, a quadruped trained in Omniverse, and the AI can run in a real robot. Digital twins. SimNet, a physics-informed neural network solver that can simulate large-scale multiphysics. BioMegatron, the largest biomedical language model ever trained. 3D-GT, Omniverse synthetic data generation.
Excuse me.
And OrbNet, a machine learning quantum solver for quantum chemistry. This is just a small sampling of the AI work we're doing at NVIDIA. We're building AIs to use in our products and platforms. We're also packaging up the models to be easily integrated into your applications. These are essentially
Sam can rejoin
open source applications that you can modify.
Of course.
Now we're offering
Jensen's gone a little long in the Q&A.
That you can plug into these applications or ones you develop. These pre-trained models are production quality, trained by experts, and will continue to benefit from
So John,
refinement.
look for Sam. He's going to rejoin
There are new credentials to tell you about the model's development, testing, and use.
Broadcast.
And each comes with a reference application sample code. NVIDIA pre-trained models are state-of-the-art and meticulously trained, but there is infinite diversity of application domains.
We were told this would be exactly an hour.
No one has all the data.
We're also told that Jensen Huang
Sometimes it's rare.
likes
Sometimes
to talk.
they're trade secrets.
I wouldn't know anything
So we
about
created
that.
technology for you to fine-tune and adapt NVIDIA pre-trained models for your applications. Tau applies transfer learning on your data to fine-tune our models.
So I gather they've rescheduled the briefing, which was supposed to be in about 10 minutes.
Yes, they pushed it back to tomorrow. So
to tomorrow.
Yes.
Is that doesn't bode well for the length of this?
No. I don't think that's going to be a problem. I don't think this is going to run. I hope this isn't going to run till tomorrow.
NVIDIA's great TensorRT to optimize the model for the target GPU system.
One of the things I was mentioning when you were gone that I'm a little concerned about is NVIDIA is really spreading themselves fairly thin. It's a big company. They have almost 20,000 employees, but still, it's hard for any company to focus on so many different areas.
Orchestrating AI.
That's true, except that all these different areas they're focusing on are building on the same basic technology set. So it's more different applications of the same pieces. So they, for example, they have a GPU microarchitecture. They take that and they apply it to the data centers. They apply it to, the smaller controllers for smaller robots, to autonomous vehicles.
To fine-tune models and run in our Metropolis Smart City application. orchestrated by Fleet Command.
I was hoping he'd address the chip shortage, because that's got to be affecting them somewhat.
And conditions routinely.
Yeah, I doubt that they're going to get into that today.
AI-enabled applications at the edge for unique, specific.
But it's definitely something we'll be asking them about during the analyst Q&A.
Here, we're building applications for a factory with multiple problems to solve. Understanding how a factory floor space is used over time, ensuring worker safety with constantly evolving machinery and risk factors.
I just think it kind of feels like NVIDIA might be setting up as the new IBM.
We start
well, there's an example of a company exactly that has had a lot of, and they had so many patents because they were working on so many areas, from storage to processors to software to enterprise. They were doing it all. So yeah, that's probably a fair
Now
parallel.
Let's use NVIDIA TAO to solve for this. With this simple UI, we retrain and adapt our pre-trained models with labeled data from the specific environment we're deploying in. We select our data sets. Each is a few hundred images as opposed to millions of labeled images required if we were to train this from scratch. With NVIDIA TAO, we go from 65% to over 90% accuracy. And through pruning and quantization, compute complexity is reduced by 2x with no reduction in accuracy, and real-time performance is maintained. In this example, the result is 3 models specifically trained for our factory, all in just minutes. With one click, we update and deploy
training
these
AI
optimized models
systems
onto NVIDIA
is definitely one of the big challenges, because in order to get a reliable and robust AI, you need a really diverse training set. And this is obviously one of the areas where we've seen problems with in recent years is training sets are not diverse enough, and they often run into problems. And having a diverse training set obviously takes a lot longer to do the labeling as well as the training of the data,
easy to adapt
the training of the models.
GTC pre-trained models with NVIDIA TAO and deploy and orchestrate applications with Fleet Command.
We have all kinds of computer vision, speech, language, and robotics models, and more coming all the time. Some are the works of our genetics and medical imaging team. For example, this model that predicts supplemental oxygen needs from X-ray and electronic health records. This is a collaboration of 20 hospitals across 8 countries and 5 continents for COVID-19. Federated learning and NVIDIA TAO was essential to make this possible. The world needs a state-of-the-art conversational AI that can be customized and processed anywhere. Today, we're announcing the availability of NVIDIA Jarvis, a state-of-the-art deep learning AI for speech recognition, language understanding,
3080 Ti,
translations, and speech. End-to-end GPU accelerated. Jarvis interacts in about 100 milliseconds, listening, understanding, and responding faster than the blink of a human eye. We trained Jarvis for several million GPU hours.
We'll be the judge of that.
Over 1 billion pages of text and 60,000 hours of speech in different languages, accents, environments, and lingos.
It's interesting that they're spending so much energy on end user applications. I just feel like that's
you can get even better for your application.
Something maybe that would be better off letting others do.
NVIDIA TAO.
Well, I think what they do is they create the foundational, they create the reference designs that then others can build on, because the NVIDIA software engineers, they know the hardware better than anybody. They know how to optimize it.
Scores 40 points for English to Japanese.
NVIDIA Jeff Jarvis with extra techno
English
panic.
to Spanish. 40 is high quality and state of the art. 50 is considered fluent translation. Jarvis can be customized for domain jargon. We've trained Jarvis for technical and healthcare scenarios. It's easy with TAO. And Jarvis now speaks with expression and emotion that you can control. No
Speaking
more mechanical
of natural language processing,
lastly,
did you see the announcement today that Microsoft is buying Nuance?
Can be deployed in the cloud.
Yeah, we heard the rumor yesterday.
At the edge of the
and it seemed like a fairly solid rumor. Not a
billion.
surprise. What was the selling price?
$16 billion.
Inside a delivery robot running on a Jetson computer.
Nothing. Chump change.
Jarvis Early Access program began last May.
I likened it to
conversational AI software has been downloaded.
Little fish being eaten by a bigger fish being eaten by a bigger and a bigger and bigger fish. Nuance was, of course, in an acquisition spree. Bought almost all the speech-to-text platforms.
That demands high quality
and now Microsoft bought them. It's the easiest way to roll up an entire industry.
We're announcing a partnership with Mozilla Common Voice, one of the world's largest multi-language voice datasets. and it's openly available to all. NVIDIA will use our DGXs to process and train Jarvis with a data set of 150,000 speakers in 65 languages and offer Jarvis back to the community for free. So go to Mozilla Commons.
What we're not seeing,
and make some recordings
because it's hidden behind a wall, is similar
and help people around the world
work in China, where I suspect that almost everything we're seeing NVIDIA do, the Chinese are trying to do as well,
90% accurate
with a lot of support from the government.
That's world class. You can still use TAO to make it even better for
I think that's almost a race, but you don't see one side of the race at all.
Yeah, certainly on the software side, I don't know if on the silicon side, if the Chinese are where NVIDIA is at. But they're certainly doing a lot of software development work. And a lot of Chinese companies are using NVIDIA silicon.
Oh, really?
Yeah, especially, again, in the vehicle space. They've got, NVIDIA has a lot of customers, a lot of OEM customers in China, especially among the EV startups, companies like NIO and Li Auto and Xiaopeng and many others.
I hope they're doing whatever they can to protect the IP, because you've got to think there's been a lot of espionage attempts to steal the IP.
The more you buy, the more you save.
I think we're going to need more enthusiasm.
One of Jensen's favorite lines from his keynotes.
Is there really?
Yeah, the more you buy, especially when he was talking about DGX. I'm surprised he didn't say it more earlier when he talks about the price of DGX.
Oh, that's pretty good.
The massive
server that got a lot better.
Conversational AI. Yeah. Interactive response, 5 languages, customized with TAO, and deploy from cloud to edge to autonomous systems.
Just remember,
recommender systems are the most important machine learning pipeline in the world.
The more you save.
It is the engine for
I don't
search,
think that's true, but
ads, online shopping, music, books, movies, user-generated content, news. Recommender systems predict your needs and preferences from past interactions with you. Your explicit preferences.
Like quantum computing, I feel like this is a historically difficult problem.
And content filtering.
Yeah.
Trillions of items to be recommended to billions of people. The problem space is quite large. We would like to productize a state-of-the-art recommender system so that all companies can benefit from the transformative capabilities of this AI. We built an open-source recommender system framework called Merlin, which simplifies an end-to-end workflow from ETL to training, to validation, to inference. It is architected to scale as your dataset grows. And if you already have a ton of data, it is the fastest recommender system ever built. In our benchmarks, we achieve speedups of 10 to 50x for ETL, 2 to 10x for training, and 3 to 100 times for inference depending on the exact setup. Merlin is now available on NGC.
NVIDIA stock up
Our vision for
$22
Maxine
so far
is to eventually be your avatar in virtual worlds created in Omniverse to enable virtual presence. The technologies of virtual presence can benefit video conferencing today. Alex is going to tell you all about it.
Hi, everyone. I'm Alex, and I'm the product manager for NVIDIA Maxine. These days, we're spending so much time doing video conferencing. Don't you want a much better video communication experience? Today, I'm so thrilled to share with you NVIDIA Maxine, a suite of AI technologies
still
that
well
can
below
improve
their
video conferencing
52-week high,
experiencing
so
for everyone.
there's still some growth to
When
come.
combined with NVIDIA Jarvis, Maxine offers the most accurate speech-to-text. See, it's now transcribing everything I'm saying, all in real time. And in addition, with the help of Jarvis, Maxine can also translate what I'm saying into multiple languages. That makes international meetings so much easier. Another great feature I'd love to share with you is Maxine's eye contact feature.
And I'm sure they do this on purpose to let the text refine as she speaks.
When I turn on Maxine's eye contact feature, it corrects the position of my eyes so that I'm looking back into the camera again. Now I can make eye contact with everyone else.
That can sometimes be a little creepy.
The meeting experience just gets so much more engaging. Last but definitely not least, Maxine can even improve the video quality when bandwidth isn't sufficient. Now let's take a look at my video quality when bandwidth drops to as low as 50 kilobits per second. Definitely not great. Maxine's AI face codec can improve the quality of my video even when bandwidth is as low as 50 kilobits per second. The most powerful part of Maxine is
It's
that
interesting. As you watch that refinement, it goes from typing out the words 50 kilobits per second
to the abbreviation.
Numerals 50 and then kbps.
It's just that flexible. Now, before I go, let me turn off all Maxine features so you can see what I looked like without Maxine's help. Not ideal. Now let's turn back on all the Maxine features. See? That's so much
She's looking
better.
at me.
Thanks to NVIDIA Maxine.
You think she is.
NGC has pre-trained models. TAO lets you fine-tune and adapt models to your applications. Fleet Command deploys and orchestrates your models. The final piece is the inference server, to infer insight from the continuous streams of data coming into your EGX servers or your cloud instance. NVIDIA Triton is our inference server. Triton is a model scheduling and dispatch engine that can handle just about anything you throw at it. Any AI model that runs on cuDNN. So basically every AI model. From any framework, TensorFlow, PyTorch, Onyx, OpenVINO,
Is CUDA a language? I know that's what they call their cores on their GPUs.
Yeah, there's a language.
It's like OpenCL.
It's actually, I think it's more. It's more akin to OpenGL. More like a framework, really, I think, than a language.
Okay.
Triton is fantastic for everything from image to speech recognition, from recommenders to language understanding. But let me show you something really hard: generating biomolecules for drug discovery. In drug discovery, it all comes down to finding the right molecule, the right shape,
this is
the right
kind of like
interactions with
folding
the
at
protein,
home, where you
the right pharmacokinetic properties.
protein
Working with
folding.
scientists from AstraZeneca, NVIDIA researchers trained a language model to understand smiles, the language of chemical structures. We developed a model with Megatron and trained it on a superpod, then created a generative model that reads the structure of successful chemical drug compounds to then generate potentially effective novel compounds. Now we can use AI to generate candidate compounds that can then be further refined with physics-based simulations, like docking or Schrödinger's FEP+. Generating with a CPU is slow. It takes almost 8 seconds to generate one molecule. On a single A100 with Triton, it takes about 0.3 seconds, 32 times faster. Using Triton Inference Server, we can scale this up to a superpod and generate thousands of molecules per second. AI and simulation is going to revolutionize drug discovery. We provide these AI
Jensen
capabilities
a
to our
motorcycle
ecosystem
rider?
of millions of developers around the world.
Just wondering why he's wearing
Companies
leathers.
are building their most important services on NVIDIA AI.
That's
Best Buy is using
it's his
Morpheus as the
uniform,
foundation
just
of
like
AI-based anomaly
Steve
detection in
Jobs
their
used to
network.
wear the black turtleneck
GE Healthcare
and jeans.
has built an echocardiogram that uses TensorRT to quickly identify different views of the wall motion of the heart and select the best ones for analysis. Spotify has over 4 billion playlists. They're using Rapids to analyze models more efficiently, which lets them refresh personalized playlists more often. This keeps their content fresh with the latest trends. WeChat is using TensorRT to achieve 8 millisecond latency, even when using
This explains why
natural language understanding
NVIDIA
models
has to
like
do
BERT.
so much software.
This gives
These
them more
companies
accuracy and relevant
aren't going
results
to
when maintaining
devote
real-time
an entire
response.
team
Yeah,
developing software to
it's
do this,
great
and it
to
would
see
take them so
NVIDIA
long,
AI
it just wouldn't be
to
practical.
build these amazing AI
Right, they
systems.
don't have these customers don't have the
NVIDIA AI on
capability to
EGX
do this sort
with
of
Aerial
work.
5G, the AI computing platform for the enterprise and edge.
It's almost
next wave
in this
of AI.
arena anyway, as if you're going to build the hardware,
Drive
you have to
AV
build the
is our
software.
AV platform and service.
Yeah.
AV is the most intense machine learning and robotics challenge.
Oh, here we
One
go.
of the hardest,
Here's my
but also
area.
the greatest impact. We're building an AV platform end to end, from the AV chips and computers, sensor architecture, data processing, mapping, developing the driving software,
One of the things that strikes me is NVIDIA takes long bets.
fleet command operations to road
They're
testing.
looking ahead to what
All
is
of it
going
to
to,
the
what are going to be
highest functional
giant growth
safety and
industries,
cybersecurity
and
standards.
positioning
None
themselves
of
so
these
that
things are openly available, so
they
we
can take
build them.
advantage of it should it
We
take
build them
off.
in modules. So our customers and
Yeah,
partners
and in this kind of space, when you're designing chips, you almost have to do that because the lead time, when you go through design and fabrication and testing, it takes a long time to get there.
Orin is a giant leap over Xavier. The more developers learn about AV, the more advanced the algorithms become, and the greater the computing demand.
Of course,
More
Tesla's
computation
contention
capacity gives teams faster
we need to design the
iteration
chips
and speed
because
to
we've
market,
got the data.
leading some to call TOPS the
And
new
so only we are in a
And
position
many
to
are
really do
realizing
the
that
right
reserve
thing. But I
computing
think there is
capacity
such a
today
skill set
is an
involved in designing
opportunity to offer new services
the
tomorrow.
AV hardware and
NVIDIA
software
Drive is an open programmable
that's important
platform
too. And I don't know if
that
Tesla
AI
has that
engineers all over the world
broad
are
skill
familiar
set.
New
compared
AI
to
technology is
NVIDIA.
being invented on NVIDIA AI
and
constantly.
from what I've heard from people that actually know chips, they're basically the chipset the chip that Tesla designed is really a very single purpose chipset. It's not very flexible, and if they
position, I think,
bet on the
all of
wrong
this
direction,
is it's a mistake to spend a lot of energy on hardware. Put the energy on software.
Except that if the software doesn't work on the hardware, well, there's only so much you can do in software. You have to have some compute power.
I'm extending the metaphor from his choice of cameras over LiDAR, for instance. We don't need LiDAR. We can use cameras.
Well, now they're not even using the radar sensor that they have. They have one radar sensor.
Right.
4 domains, virtualized and isolated.
It's such a hard problem that I don't think it's a mistake to say we can solve it all in one area. I think you need to throw every bit of technology you can at it.
And even if you could solve it in one area, it's also because it's a safety critical system, you need redundancy and diversity.
Has to be perfect.
To be doing it in different ways at the same time.
Right. Is NVIDIA's platform competitive?
Absolutely. It has become much more competitive. They've now, they've always been very competitive on the compute side, but now, they've got all these other tools like this Hyperion platform he's talking about here, which is
8 cameras, 4 fisheyes, 3 in cabin, 9 radar, and 2 LiDAR.
Yeah.
Going to production.
But that's expensive, and I think Elon's also saying, I don't want to spend all that money.
Yeah. Well, but the cost of those components is coming down substantially. There's now LiDARs that are under $1,000, and in the next couple of years will be down into the low hundreds of dollars or sub $100.
Drive Atlan.
Yeah, so this is NVIDIA's new SoC
on one chip. More than the total compute in most level 5 robo-taxis today. To achieve higher autonomy in more conditions, sensor resolutions will continue to increase. There will be more of them. AI models will get more sophisticated. There will be more redundancy and safety functionality.
So this has the Bluefield DPU in there. It's got tensor processing units, next generation GPU architecture, the Grace ARM cores.
All of their technologies.
Yes.
AV
and one chip that they claim will do 1,000 tops.
Wow.
The software you invested billions in today must carry over to the entire fleet and to future generations. The Drive Atlan, the next level, one architecture.
This one's targeted
at 2025 The car industry has become a technology industry.
And look at that,
Future cars are going to be completely programmable computers, and business models are going to be software driven. Car companies will offer software services for the life of the car.
Well, Canoe is an American company, so is Faraday.
As a product to sell, but as an install base of tens or hundreds of millions to build upon, creating billions in services opportunities. The world's big brands have giant opportunities. Step 1 was going electric. Now the big brands are making their new fleets autonomous and programmable. Orin will be powering many next generation EVs. And with Mercedes, we're building the end-to-end system. The world moves 10 trillion miles a year. If only a fraction of these miles were served by robotaxis, the opportunity is giant.
The vast majority of companies developing automated driving are using NVIDIA chips, at least in part, as part of their compute platform.
Cruise is a GM project, right?
Yes.
The internet moves electrons. Trucks move atoms. The rise of e-commerce is putting intense pressure on the system. One click, and a new TV shows up at your house. Another click, and a cheeseburger shows up. This trend will only go up. The US will be short by 100,000 truckers by 2023. The EU is short 150,000 truckers already. China is short 4 million drivers. So ideas like driverless trucks from hub to hub, or driverless trucks inside a port or warehouse campus are excellent near-term ways to augment with automation.
I really think that notion that everything that moves will someday be autonomous is quite interesting. I mean, that's where they see this market going.
You can see how important it is to our work.
That's why it's
again,
so important.
you know, it's that someday, you know, eventually.
It's not. It's another long bet.
Yeah.
In the case of Isaac, the digital twin is the factory in Omniverse. In the case of Drive, the digital twin is the collective memories of the fleet captured in Omniverse. The Drive digital twin is used throughout the development. It's used for HD map reconstruction.
So several years ago, NVIDIA announced their first generation simulation platform for AV testing. And now their second generation, they're migrating it to Omniverse that we saw earlier in the presentation. So you have much higher fidelity for the simulations.
This is also a response to Musk saying, we've got the data. You're basically collecting the data with your fleet every time you're using it.
Except that they're not actually collecting that much data. The vehicles don't have that much storage on them, and there's not enough bandwidth to ship most of that data. So they're only collecting very short snippets, at various times.
There he goes again. Oh, his whole house is gone. Looks like the Waldo Tunnel, but it's not. It's fake.
Yeah, this is all simulated. This is an Omniverse.
So besides Mercedes, are any other big car companies choosing the NVIDIA platform, or for instance, Audi or GM?
Yeah. So Volvo is using the Orin processor for their automated driving system that's debuting next year. GM, Ford. Let's see. Almost
are
everybody.
They dominant in the industry then?
Yeah, in terms of the silicon. So not everybody is using their SoCs. In many cases, like in case of Cruise and Argo, which is Ford and Volkswagen's partner, they're building their own custom compute platform, but they're using NVIDIA GPUs as part of that. So, in some case, so in those cases, they're mixing and matching, in sometimes x86 CPUs plus NVIDIA GPUs and some FPGAs. In the case of Mercedes-Benz and Volvo and some of the Chinese companies, they're just using straight up Orin or Xavier chips, without an x86 in there or some other CPU. And in the case of Mercedes, they announced this last year. Mercedes, for a 2024 program, they're working with NVIDIA to develop a complete centralized compute platform for their next generation vehicles. And they're using NVIDIA's software, their Drive AV software, to do level 4 automated driving capabilities.
I think it's very smart. I think NVIDIA realized that they needed greenfield areas to sell into because Intel was so dominant, and they were smart. They picked the right green fields, and now Intel is fading, and NVIDIA is very well positioned for the next couple of decades.
Yeah, absolutely.
This is where Jensen better pull a TI out of the oven.
Incredible to think how much was done in this last year. I spoke about several things. NVIDIA is a full stack computing platform. We're building virtual worlds with NVIDIA Omniverse, a miraculous platform that will help build the next wave of AI for robotics and self-driving cars. We announced new DGX systems and new software, Megatron for giant transformers, Clara for drug discovery, and cuQuantum for quantum computing. NVIDIA is now a 3-chip company with the addition of Grace CPU, designed for a specialized segment of computing focused on giant-scale AI and HPC. And for data center infrastructure processing, we announced Bluefield 3 and Doka 1. NVIDIA is expanding the reach of AI. We announced
so for that
Atlan new platform,
processor for next-gen
NVIDIA
AVs,
EGX with Aerial
that
5G
DPU in there, that
to make
data
AI
processing unit,
accessible
is going to enable
all companies
400
and
gigabit
industries.
per second data
We're joined
transfers
by the
within
leaders
the
of
vehicle.
IT, VMware, computer makers, infrastructure software, storage, and security providers. And to lower the bar to the highest levels of AI, we offer pre-trained models like Jarvis Conversational AI, Merlin Recommender System, Maxine Virtual Conferencing, and Morpheus AI Security. All of it is optimized on NVIDIA AI Enterprise. And with new tools like NVIDIA Tau, Fleet Command, and Triton, it is easy for you to customize and deploy on EGX. And Drive, our end-to-end platform for the $10 trillion transportation industry, which is becoming one of the world's largest technology industries. From Orin and Atlan, the first 1,000 TOPS SoC, to Hyperion 8, a fully operational reference AV car platform, to DriveSim, to Drive AV. We're working with the industry at every layer. 20 years ago, all of this was science fiction. 10 years ago, it was a dream. Today, we're living it. I want to thank all of you, developers and partners, and a very special thanks to all the NVIDIA employees. Our purpose is to advance our craft so that you, the Da Vincis of our time, can advance yours. Ultimately,
wait to see what you're doing.
NVIDIA is an instrument for you to do your life's work.
That's great.
Have a great GTC.
What's in the oven? Okay, the olive oil changed. No, TI. They're disassembling his kitchen. You think it was all fake?
No, that actually was his kitchen, where his actual kitchen at his home.
Yeah.
This is just a digital twin of his kitchen.
There were a few things I noted. There were 3 different pepper mills. I'm not sure why, maybe 3 different peppers he likes, but his choice of wok oil was excellent. Highly recommended. Sam Abuelsamid, who is, of course, a principal researcher at Navigant Research and my car guy on the Tech Guy radio show. His own podcast is the Wheel Bearings podcast at wheelbearings.media. I'm so glad you were here to explain all of this. You've been covering NVIDIA longer than anybody I know. And it started, of course, with self-driving vehicles, but you could see that NVIDIA is firing on all cylinders. Maybe sometimes I think too many cylinders. We'll see.
Maybe,
but they're making some big bets.
So far they're succeeding. They haven't tripped yet. In fact, I've got an NVIDIA chip in my wife's Honda Civic, powering the infotainment system, and so they've been in automotive for quite some time, in doing things like infotainment systems, and increasingly now for driver assist systems, and moving forward into the automated driving systems, the fully automated driving systems. So, it's just one of the many areas that they're leveraging the technology that they've developed, both in the silicon hardware as well as the software capabilities and all the tools to utilize it. The simulation tools and training models and all kinds of other things that allow developers that don't have as much expertise as they do in-house to get a quick start, to get up and running. One of the things that really got NVIDIA going quickly in the AV space was back in 2015. They launched a product called Drive PX, which was their first development compute platform for AVs. And this is before they had most of the software. But basically they had the computer. It was about a $10,000 box that all these startups that jumped into the automated driving space could go and buy one of these, drop it into their car, and be up and running fairly quickly. And one of the reasons why we saw so many startups jump into AV was because you could, for maybe about $50,000-$60,000. You could go, buy a car. If you got some seed funding, you could go buy a car, buy one of these NVIDIA Drive PX boxes and some sensors, and put it on the car and get a pretty reasonable demo up and running in probably about 4 to 6 weeks. Then of course going from that to something that's actually production ready and safe and robust is a whole other story, which is why a lot of these companies have fallen by the wayside. But from that, starting point, they have continually iterated and made more and more powerful systems. And those companies that are still using NVIDIA, are continually getting new upgraded hardware and software to go with it. And, a lot of this stuff is starting to go into production now.
I imagine tomorrow in the briefing, you and other analysts will ask the consumer questions, because he really didn't address any of the questions that I'm sure the media and the press and we had. Things like, why is it so hard to get an NVIDIA graphics card for my computer? What are you doing? For instance, they've announced cards that cannot mine Ethereum, hoping to be able to offer those cards to people who just wanted to play video games. I'm sure there's a lot of questions about chip shortages and shortages in hardware. None of that he addressed, nor did he address why there's no TI version of the 3080 or anything like that. It was really a more high-level conversation about the goals of NVIDIA and the kinds and the different product areas they were working in. But I think very impressive, and obviously the stock market impressed as well, as NVIDIA stock took a big jump as soon as he started talking. Sam, I thank you so much for joining us. I thank you all for watching our special coverage of NVIDIA's GTC21 Keynote. Jensen Huang, the CEO, laying out a vision for a company that I think is well positioned to become, as one of our chatters said, the next IBM. Thanks for joining us on this TWiT News special. Have a great day.